So, hi everybody, hope you're well. So today, as said, we are going to talk a little bit about ChatGPT, which is the root of a lot of concerns and fascinations by people in general. So it's really trending right now. So we are going to talk about it today. So a little table of contents. So first, we're going to deep dive in machine learning. Then we're going to see the use cases and the actual applications of ChatGPT in our today, in our everyday lives. Then we are going to see the different fallbacks and the problems ChatGPT offers. We are going to see how LLMs and all these generative AIs are actual industrial revolution. Then we are going to see how about is the future. So what does LLMs and generative AIs offers us? And then we're going to end with a quick question and answers for you to answer every question that you could have. So first, what is ChatGPT? As you may know or not, ChatGPT is an artificial intelligence, of course, but generally you would want to portray yourself about artificial intelligence, seeing these kinds of images on the internet, or maybe these that don't really mean anything. And artificial intelligence is for developers in general. It's a bit of a misconception because, like iRobot, exactly. For example, iRobot or any other movies, and it's a kind of a misconception because artificial intelligence are not that hard to understand. Generally, they tend to say it's an artificial intelligence, but we don't really see what's under the hood. So we have a lot of memes as developers, like it's just basic conditions, and they talk about it like AIs or complicated stuff, but it's just like regular program. So I'm going to start by explaining what is machine learning, which is different from this, and this is the whole thing about ChatGPT and why it is extraordinary. I'm going to be as clear as possible, but you may not understand everything. I'm going to try to let you understand everything. If you have any questions, make sure you wait longer, because maybe I have answered directly in the next slide or anything. And of course, we're going to have to have the weekend, so sit tight. Okay, so what is machine learning? Actually, machine learning is a program that makes statistical analysis. So it learns from data simply to make a prediction. It's pretty much all what it is and what it is used for. And in machine learning, we use what we call artificial neural network, which are interconnected units. And every unit, it receives a signal, which is a number, because we use a lot of numbers and math, as I said, because it's statistics. It performs a calculation on it, which is generally a basic calculation, and it outputs a result. And that is pretty much it. You can have as much neural network as you want and models as you want. And good to know, because artificial neural network are actually modeled from real neurons that we have in our brains. They took the exact same architecture we have as human beings and other animals, and they modeled it into mathematics. It works pretty much the same way. So yeah, as I say, there is a lot of models that do a lot of things. It's not really interesting to deep dive into everything, but it can get complicated really quickly. And generally, we have two sides. We have the input and the output. So in the input, we have all the data. Like for example, here we have the age, gender, the nursing home, etc., diabetes, cancer. There is a hidden layer. This is the whole model. It can be one layer, or it could be like a lot of layers. And then we have an output, which gives the mortality rate, for example. So there is a brief history of machine learning. It started in actually in last century, over 70 years ago. There's the first neural network that was made using electricity only. Then there is the Turing test. I don't know if any of you know the Turing test, maybe from Alan Turing. I don't know if you know. No. No, that's one of the achievements of Alan Turing in the war. The Turing test is different. It's to test whether how do you say whether an artificial intelligence can be with a human being, and the human being like a test for artificial intelligences to attest if it is good or not. Then we have the Frank Rosenblatt's perceptron, which is actually the first ever machine learning machine that can see the world around us and take a decision. For example, we would show it a card with two marks on it, and the machine was able to know if the mark was on the left side of the card or the right side of the card, simply like left or right, and he would know it with the camera. And exactly the same thing with neural networks, with a big machine that was the size of a room with four tons. Now we are not like this, of course, but it was pretty amazing that they was able to do this in 1957. Exactly, Gregory. They embedded in mainframes. They embedded neural networks directly in mainframes, and they attached a camera to it, and he was able to take a decision. Then we have the Stanford card, which is pretty much the same thing, but with action associated to it. So they put a camera with a computer, and the card was able to move and dodge chairs that was inside a room. So he was able to dodge 10 chairs and move through the room in 9 hours. So that's pretty far from what we can do today, but pretty amazing in 1979. Then we have the Deep Blue that beat the chess master Kasparov at chess in 1997. Then we had the invention of deep learning in 2006. Sorry. And then we had AlphaGo, which is an artificial intelligence that became the #1 ranked Go player, which is a board game pretty much like chess, but it's Korean or Japanese. I don't remember. And then finally, we had the invention of the transformer architecture that changed everything because it enabled some engineers in Google in OpenAI to create the first GPT model, the GPT-1. But let's forget about all these things, and we are going just to focus on two things: the deep learning and the transformer, and of course the GPT, because they are the main things about ChatGPT. So first, what is deep learning? We hear it all the time, pretty much like machine learning, but we don't really know what it is. Some people tend to confuse it with machine learning, something that it may be a completely different thing. Actually, deep learning is just a subset or another field of machine learning. And the goal is pretty simple, like this in a phrase, to detect patterns, but inside raw data, by discovering key features through multiple levels of neural networks. So the definition is pretty complicated right now. You may not understand fully, so we're just going to break it down in some words or expressions. So pattern detection, it could be anything actually. Like for example, it could be a shape in an image. For example, we have an image and there is a square inside it that we would want to detect it, or the signature of a voice. Like for example, when I'm speaking and someone else is speaking, we don't have the same voice, and this could be a pattern that we would want to recognize to know who is talking. Then we have the raw data. So it's pretty much the input data. For example, if it is an image, it's going to be images. If it's a sound, it's going to be sound, of course, and there is a lot of data or possible data that we have, and the particularity of the raw data for the deep learning is that it does not need to be organized or classified. That's the main difference, because in machine learning, to be able to process a lot of data, you have to classify it, so organize it in a certain manner that the algorithm will compute it easily. And with deep learning, you don't need to. Then you have feature discovery, and it's very important also in deep learning. So in the raw data, you have key characteristics that we call features, and these should be discovered. I'm gonna explain a little bit more right after. For information, this process is called data mining, which is a cool word for not saying, as usual, not a lot of things. In AI, they love to do this, like put crazy words that nobody understands and that you see, and like wow. That's why AI is such a boom economically, because you can just put whatever word you want, exactly like crypto or Web3. You can just put random words, like weird things that no one will understand, but they would love to use it again, and no one knows what it means either. So, and then you have multiple levels of neural networks that are stacked on in layers, and that's why we use deep learning, because in machine learning you can have like one layer at the center that does all the computation, but with deep learning you're gonna have at least two, and that's why we call it deep learning, because there is a lot of layers. So to be simple, the difference between machine learning and deep learning is pretty simple. You're just gonna give him like a lot of data, for example, 1 million images of cars, any cars, and the algorithm, the deep learning algorithm, will learn alone what really composes a car. Like, for example, 4 wheels and glass windows. That's a basic representation of a car. And then it will be able to recognize all the other cars, whether they are blue or red, big, small, etc. Because the key specificity, no, I didn't use specificity, what did I use? Characteristics, that's better. So the key characteristic that I was talking about is exactly this. That's 4 wheels, and then you have a glass window. And it will learn by itself this, because it's going to have the better, it's going to have better results in the tests. And that's the whole thing about deep learning, is that it finds itself what composes an image or a sound or anything, and what's best to detect inside data that will give us the desired output. I know it's a little bit complicated. I'm going to get the abstraction of a car. The category said it's not really the abstraction of a car. It's more like the key characteristics that ensures the algorithm that it is a car, or it thinks, of course, it's a car, because it doesn't really know all the time for sure. But it's more like the key characteristics of something it have to find. So we talk a little bit about deep learning, and now we are going to talk just a little bit about the transformer architecture, which is very important to understand how GPT works and why it is so good. So in deep learning, we have transformers. Transformers is an architecture that was invented very lately in 2017 by engineers in Google, and they found out that they could model a neural network to actually put words that we have on a sentence in a context, exactly like a lexical field. For example, cars, bus, I don't know, like truck. All this is the same lexical field, and it's able to put these words in a context. And to give them a rating of importance in a sentence. If you think about it, it's exactly like how humans would interpret a sentence when you speak about anything, like or when you read, you find the keywords inside the phrase, like for example the subject, the verb, and you know exactly how to interpret the phrase, because these words are the most important. There's a lot of filler words in languages, but generally what's most important is the subject and the verb, and that's all we need to know what the sentence is about. And this architecture, so it was made to mimic actually human attention. Attention is all you need is a book that was not a book, but like the title of the paper, the scientific paper that the engineers at Google released, because it's exactly what what it is. They just took the concept of attention from human beings, and they were able to translate it into an algorithm. And of course, it has to be trained on a lot of data, and executed quickly. And that's the main thing about transformers. You can feed it a lot of data, and the training won't be too long. And that's also a pretty big thing. That's all I'm going to talk about with the transformer, because it's really complicated. But all you need to know is really like the concept of attention and prioritization of the words inside the sentence. And then the same year, they took this transformer, because it changed everything, and created the first GPT model, which stands for Generative Pre-trained Transformer. So a transformer that is trained on a lot of data, and it's able to generate human-like responses that are pretty impressive with natural language. So it actually speaks a language that we understand and can use every day. And it processes natural language too, so we can ask him things. And also, the craziest thing is that in less than a year or 2 years, everyone would use these kinds of architecture to make what we call now large language models. That's pretty much models that we feed with a lot of data and a lot of textual data. So we say LLM. Pretty much everyone began to use this kind of architecture, and it became mainstream very fast. So for example, if we talk about the versions, the first one, so it was released in 2018, and it used 4.5 gigabytes of data from 7,000 unpublished books. And then 1 year after, for GPT-2, they just decided that, okay, we're going to do 10 times more. Why not 40? From 8 million documents and 45 million web pages. And then why not? They said, okay, it works great. So 1 year later, why not do a times 10 even more? So they decided to put 570 gigabytes of data. So they use a web crawler that actually index all the data from the internet, over 500 billion tokens. Tokens are the little words of any words. So that's 500 billion words, and 2 book corpus. That's 2 book corpus at the size, I think, of the first GPT. And then we don't really have information because they try to hide it from us, so it's undisclosed. But there is, after the GPT version 3, there is 3.5, which is pretty much the same, but that runs faster in training and with the results generation. So that's when ChatGPT went viral, because it would answer any question very fast. And then we have GPT-4. The corpus size also is undisclosed, but this time it's also trained with the human feedback. And you can feed images as prompts instead of just text, which is also pretty crazy. So as you can see, it's moving pretty fast, and it could be a little bit frightening, because what are they going to invent in like 10 years from now if they can move that fast in less than 5 years? That's pretty crazy. But actually, what is ChatGPT? Because we talked about machine learning models, we talked about deep learning models, and all these things, corpus, attention. Okay, that's great. That's the theory. But how do you use ChatGPT? What is it? I'm sure you have seen it, of course, ChatGPT. And the whole product consists of one single chat input. And basically, you can ask whatever you want. That's pretty crazy of a product. That's a little bit funny, but it answers pretty much everything. And for me, the best way to learn how ChatGPT works was actually asking ChatGPT. So you could ask ChatGPT how he compute a prompt. And I prefer to use like some tokens, explain it like you would be to a 15-year-old or a 10-year-old or 5-year-old if it's really, really complicated. And it just like break down everything it does, and it gives you an answer that is clear. And sometimes a lot of my prompts when I use ChatGPT, I ask him to give me the reference and the sources, so I'm sure that what he says is actually good and sourced. Okay, that's great. So that we have a chat that answers pretty much everything. That's, of course, very good. But what can you do precisely with it? I'm going to take two examples because we are Extia, of course. So for developers like myself, I use ChatGPT pretty much every day using another product from OpenAI that's called Copilot. It's not the Copilot from Microsoft because they took the same name and applied it in Windows, but it's GitHub Copilot. And by embedding it in the text editor that I use every day to code, when I'm typing, it proposes something, and I can just pretty much hit tab or enter, and it auto-completes, taking into account the context of what I'm developing. So it knows what I will do before I even do before I even think about how I want to do it. So it's really much a time saver, of course. And for complicated tasks, it's cool. Like it's pretty great. But sometimes it does mistakes. So the best thing about this is like for simple tasks that actually takes a lot of time. Like for example, we need to translate a file inside in a weird format, and it just does because he understands the format. He knows the languages, of course. He knows any languages. So you can just hit tab, enter your language, and he will know. He can even propose you some languages that you want to add. You have a question? Dangerous for security. Actually, you can refuse to send informations back to GitHub. So you can choose either to send it or not. Of course, you don't know if they really decide not to send it because they can do whatever they want. They have the data, so you don't know. But you can choose to opt out or opt in for the data aggregation. And actually, this model that I use for coding is a little bit different from the ChatGPT one. It's the same model, but a little bit different because it's optimized for coding. So that's pretty much the only thing. And also, you can just highlight some code, and inside the coding interface, you can ask him to explain what it does. why it's here, etc., etc. You can even I don't know, like say, ask him, how can I improve my code or this function, or what is the algorithmic complexity of it, etc., etc. So that's the kind of thing. Personally, I use it pretty much every day for basic task that is time consuming. And then for HRs or business managers, you can actually use ChatGPT too inside your work of every day. For example, you can just give him a use case or a problem that you actually have. For example, I have a consultant in IT that does this, but you don't really have every mission that you would want. So what technologies this consultant would be able to learn, hence have I don't know, like other missions and all this stuff. So you could ask him, and he would give you examples of skill sets. For example, you do React. A React dev would be able to learn Angular, for example, or a Vue. Or you do a Node.js. You have to know, for example, Express or MongoDB. It's pretty easy to use. They would know how to use. Or you do a little bit of Python. Okay, maybe you can learn Django, etc., etc. So that's pretty basic. A pretty basic example that you may use already. I don't know, but it's pretty great to have these two. Also, I have a lot of the same questions generally about ChatGPT. Is okay. There's ChatGPT, that's great, but how do I use it, and what can I ask to him, and how? And for me, the perfect way to know how to ask ChatGPT is actually asking ChatGPT how to ask him. So that's pretty much a lot of things that I do. I just help him. I just tell him, okay, help me to like write a good prompt, because I don't know how to write a good prompts. So just give me useful prompts that I would need in my everyday life. Exactly, ChatGPTception. That's exactly what it is. And he's going to give it to you. I guess it works every time. If your initial prompt, when you ask him to help you, to give you some other prompts, if you give him a lot of context, the more precise the responses are going to be. So generally, do not hesitate to like give a lot of context. You guys hear me? I think you do. Maybe yes. Okay. Okay. Pretty well. So yes, to continue, because I don't remember what I was talking about. How about the fallbacks? So that's also an interesting question, and there's a lot of fallbacks actually for generative AI. First of all, the ethic. By giving it training data, you pretty much never choose what you give him, because there is a lot of data, as you could see, like 450 gigabytes, a lot of data, a lot of documents. So you can kind of perpetuate like society bias from the training data. So it doesn't know how to think by itself. It only knows how to express what it learned. So that's not ideal if you are looking for original ideas and solutions. Of course, there is the privacy and the consent problem. So, okay, I'm putting a prompt. I'm giving I don't know, like informations about my company. How do I consent to give it? Will it be safe, etc. And of course, the responsible use of the generated content. We can never know what people will do with the generated content. What if, for example, they generate something and they will scam someone, or I don't know. You can never know what they will generate with it. So there is an ethic problem with this. It's really, really dependent on data. So of course, that's machine learning, and as we could see, it's all about data. But what if you feed the generated content that you generated actually with ChatGPT back to ChatGPT with training? I don't know if you saw, maybe for the ones who use ChatGPT, last month, the ChatGPT had really a big problem. It's kind of like hallucinations. Exactly. That's machine learning hallucinations. There were a problem with ChatGPT, like the responses it was giving, it gave, were really bad, but like very, very bad. And there was a big problem actually at OpenAI. And one of the problem was there was a lot of web pages on the internet that was actually generated with ChatGPT, a lot of content on the internet. And this content was fed back to ChatGPT, leading to results that was unusable by the people. So they fixed it. Hopefully it's going to work. That's why they use now manual validation on the data, as we saw on the previous slides. But it was a real problem. So it's actually a real fallback. And of course the control of the quality of the training data set we just talked about. Also, there is a big environmental fallback. Generative AIs, so ChatGPT and all others generative AIs, for example, Midjourney or all these things, they are extremely resource intensive. They use a lot of electricity, a lot of resource. So it's not really green, as per se. They're trying to, as I saw some articles, they're trying to reduce their impact. But generally speaking, training an AI consume a lot of resource, because it's only like big farms of GPU, of graphical cards, and it's very, very expensive in resource. And of course, the user dependency. What will happen to us? Are we going to be able to think normally, freely, like normal human beings, by using these kinds of tools? Are the people going to be dumb? Actually, way dumber than they actually are with TikTok and Instagram. What will happen to us? That's the big thing that, for example, Elon Musk is not really a big fan of AI. He thinks that they're going to be replacing us in the next years. Maybe it's what's gonna happen. And yeah, and of course, are we going to be able to take reasonable decisions without them when there is a problem, or when we don't have access to it? But of course, there is a lot of fallbacks. But LLMs are really an industrial revolution. Why? Because you can communicate with computers way more efficiently than before. You can actually use natural language, so you can talk to the computer and it will understand. For example, we have a lot of how do you say, of GPT-like instances that you can run inside your computer, and you can ask him to do operations in your computer. For example, or can you move all these files that look like this, of this type, that are named like this, and you put it in separate folders here, and the bot is able to do exactly what you said on your computer. So it's very, very efficient way to communicate with computer. You can personalize it 100% tailor-made to fit a use case. I just talked about the fact that you can control your PC with it, but like, for example, you could, I don't know, drive a car by talking to it, like go right, go left, I don't know. You can make everything. And of course, you can automate pretty much everything and transform any data to one form to another. And that's also a big thing because a lot of time that you take in a day is, for example, I don't know, actually like we are doing today, we are having a meetup and you would like to, I don't know, like have some notes or something. And to do that, you would have to take a pen or open something on your PC and type as I am speaking. So it's pretty time consuming and you won't, for example, focus on what I'm saying. But with these kinds of algorithm of GPT-like tools, it could hear what I'm saying, convert it to text, and make a summary at the end and send it to you by email, for example. And it's very, very, very efficient in our lives, and it could change a lot of things. And of course, it's a very big innovation catalyst, exactly like the dot-com bubble that we had in the 2000s and the 90s when internet went crazy. So I think it's going to boost innovation and also opportunities because a lot of closed industries to the public are going to be now open thanks to it. For example, making a website could be pretty difficult for a lot of people, like something they don't even think about doing. For them, it's like something that does it as a living that could do it. And now with GPT-like LLMs, we could be able to, we already can generate entire websites just by prompting. You just type, okay, I want this, I want a bar with these icons. You put this inside the text. I want a link here, link here, link here. You just talk and it does. That's pretty amazing. So it's going to like open a lot of industries to the public. And of course, how about the future? What will the future be, will preserve to us? This is my personal opinion. Okay, you won't have to because it's just like it's a prediction, and I'm not 100% sure about this, but this is more like what I think will happen in the future regarding LLMs, because no one knows the future. I think in short term, and it's already happening, the multimodality of generative AIs. What I mean by that is that, for example, you have AIs to generate, I don't know, like images. You have AIs to generate videos. You will have AIs to generate, I don't know, like video games and all this stuff. And I think we are going to have like big hubs of generative AIs that you can actually speak to or type to, and that will use a lot of these things to create bigger ones. That is the synthesis of all these things. There is a lot of businesses that are trying to do this. For example, for video games, or they're trying to make movies entirely from AIs. So that's the thing. Integration with other technologies. It's happening right now too, because ChatGPT now has what we call plugins that you can actually plug directly in ChatGPT, and it can interact with the external world. So, for example, sending mails and I don't know, like a lot of things. And you are going to have also LLMs, so GPT-like chatbots for everything. So you can put GPT behind any word, and I'm sure 100% it's going to exist in like 2, 3, 4 months. You can put really like anything behind GPT, like for example, I don't know, like sound GPT, flower GPT. you can have 3 GPT, light GPT. I don't know. You can put anything. It's going to exist. So, and in medium and long term, of course, there is a replacement or disappearing of jobs. Some people say replacement, some people say disappearing. I personally think that some jobs, a lot of jobs actually, are going to disappear. For example, even my job, like I'm a developer, and last week they released an AI, which is kind of like a GPT, to not code. It's called Devin. It's pretty amazing. Like you just type and you prompt with very tailor-made prompts, and it codes better than any not better than any developer, but like it you won't know that an AI developed this, and it's made for like big projects with a lot of context. It's pretty amazing. I saw some videos of it. So it's going to open like for more jobs. For example, the prompt engineering. So I think we are going to be prompt engineers in the future, not actual. I don't know. Like I'm a developer. I'm not going to be a developer anymore, but a prompt engineer with a developer background. And we are going to use so embedded LLMs in our everyday life, and this is going to be mainstream for me. Like for example, dedicated wearables. I don't know if you see the movie Her, which is pretty amazing. It has 2 devices, one that able an AI to see, and another one that able an AI to hear what he's saying, and he falls in love with the AI. It's a pretty amazing movie because I saw it was released like maybe 10 or 15 years ago. I don't remember. And we are going right through it at the speed of light. That's really scary. But yeah. And for example, also like AI teachers, what's the point of going to school if you can have a teacher at home that does a better work and that can help you with your homework and etc. etc. So there's a lot of possibilities. And is ChatGPT the only LLM? Of course not. There is a lot of them. ChatGPT is only one of them. Like there's Gemini from Google that use Palm. You heard about Google Bard. That's just one of the chatbots from ChatGPT. You have Llama, Vicuna, Claude, Coral Falcon. You have a lot of this. Grok from Twitter. Grok is pretty amazing actually because it uses the data from Twitter in real time, so that's pretty good. But you can have a lot of fake information as well. So yep, there is a lot of LLMs, and it's only starting. Like we debuted in like what 2018. It's 6 years, and it advances like this. That's pretty crazy. Imagine what could be possible with in 10 years of development.